All right, so my talk today is 10 years of Haxe. It's actually slightly longer. My name's Hugh Sanderson, if you don't know me, but I think I've probably met most of you. So it started back around 2006, where these are the West Coast Eagles, won the 2006 Premiership, and they here to cheer me on along my fledgling game creator career. That's AFL football. So yeah, the only type of football really. So yeah. 2006 was a while ago now. I tried to put things in a bit of social context. Anyone born this century? No, I think we're all pretty old, so you probably get what I'm talking about. But you know, then those days BlackBerry ruled the spectrum. MySpace was the most visited site in the USA. The Cars DVD was released, and we watched it about 100 times in my house. So I know that one. Yeah. So the story begins about 10 years ago, a long time ago in a country far, far away. And to understand the story of my journey through Haxe, you also need to understand my journey with XhX, and NME. So I'm going to talk about the two together to some extent. 2006 was a year after the birth of my younger child. So for about a year or 10 months there, I was completely sleep deprived, didn't know what I was doing. But then all of a sudden, the sleeping patterns aligned, and I got a good night's sleep, and I got a lot more energy. So I was looking around for some projects to do, and that was the year of the indies, when any indie game creator could put a game out there, and they would sell millions of copies, get rich. So I thought, yeah, got to get myself a piece of this. So I put a game out there, and I sold one copy. So I thought, all right, 2007 rocked over, and I thought I got to try something a little bit different. Obviously, the problem with my game wasn't that it was crap; it was that I didn't have a web demo to go with it. So I thought, all right, I'll get myself a web demo, and that will solve all my problems. So I looked around at the technology at the time. The two main candidates were Java and Flash 9. So I did investigate Java. At the time, the web player was a pretty bad user experience. Good chance no one would have it installed, and even if they did, the graphics libraries at the time weren't that great. And in fact, the desktop also wasn't that great. Again, they'd have to install something, and it was kind of bloated and difficult. So maybe if Java had lived up to its promise of write once, run anywhere, this story may have ended there. But because it was just a little bit crap, really, it didn't go down that path. So then Flash 9, I had a go at Flash 9. It seemed pretty good. It had all the things needed to make a game. But you needed the Flash IDE to make a Flash game, and I was too tight to buy the Flash IDE. So I looked around, and I found this programming language called Haxe, with a capital X, which looked like it could do the job. So I made a little test demo, and it ran, but it ran like twice as slow as the native AS3 version of the code. So they're a little bit disheartened there. But then the good thing about Haxe is that it's an open source compiler, so you can jump in there and change the code. So I jumped into the code. Hadn't really done a lot of OCaml, but I managed to hack in a little thing to put strong typing on all the Flash temporary variables, and then suddenly it ran twice as fast. I thought, okay, well, actually, this is a good way of doing it. That was pretty bad code, but luckily, later that same year, Haxe actually got proper strong typing across all the variables, and everything ran faster than you could with the native Flash player. So, yeah, that was good. That satisfied me that the browser side of the equation was covered. So then I thought, okay, the browser's covered. What about the desktop? There were two targets at that stage, JavaScript and Nico. obviously JavaScript was never going to go anywhere. No one would ever end up using JavaScript for anything. No desktops, no servers, completely useless, which left Nico. So, to get a window library up and running, there was actually already one there. There was this NME library, which I thought, okay, give it a go. Didn't want to rewrite my little demo code, so I just wrote a bunch of functions that took the code that as I had written it in Flash and just changed the calls to make the drawing calls into the NME library, such as draw line, draw circle, that kind of thing. And actually it worked, and it worked not quite as fast as Flash. You can see 2 milliseconds versus 4, so it was twice as slow, but still acceptable. And that little translation layer was called Blink. But twice as slow is still slower. It's not great. So then I thought, well, how can I make this faster? And I looked at having had some success with hacking the Haxe compiler earlier to get the Flash target faster. I thought, well, I should do some different sort of output. So that's where the idea of CPP came from. I jumped in and had a go, and it worked. And at the time, there wasn't extensive unit testing to tell me that it wasn't working. That would come later. So it worked for exactly the amount of functions that I needed to call, and so I was pretty happy with that. The initial version was based on reference counting, so not really a garbage collector. And when I ran it like that, it was somewhere in performance between Nico and Flash. So it was a boost over Nico, but still hadn't closed the gap on Flash. And then in October of that year, I replaced the reference counting GC with this Bohem GC, which is the same as what Nico was using at the time. And then all of a sudden it was running a couple of times faster than Flash. So I was pretty happy with that. And that's kind of the beginning of the end of me trying to write a game and instead trying to write a compiler. So I sort of got sidetracked at that point. So comes along 2009, and the iPhone had been released just not really that long ago. And because Haxe and NME and was all kind of running nicely now, I decided, why not try the iPhone? So we ran it on the iPhone, and I was running really slowly. And it sort of worked out that it was actually probably the Bohem GC, which involves some system calls to detect when certain areas of memory have been changed. So I replaced the Bohem GC with an internal version called XhX, and then all of a sudden the performance became quite nice on the iPhone. So changing the garbage collector is a theme that will run through this talk. I think you're fine. It's already happened 3 times, and it's still happening today. So that was about 10 years ago to the day. I had the version running. It could run on. It was quite satisfying that it could run on an iPhone, which native language was Objective-C. Even just by outputting C++, I thought, well, maybe I'm going to have to do something different. But the Objective-C also has a ++ version, so it's effectively like a subset of what runs on the phone, and it sort of ran. So that was then good and locked in. So yeah, with the custom GC, the performance on the iPhone was good, and certainly had locked that in as the way forward. So 2010, I revisited the NME architecture, and at this point, I'd basically hijacked the NME project for my own evil means, and it was no longer simply an SDL layer, but now it was a Flash emulator or a Flash runtime supporter. But in 2010, in order to get some more performance out of it, especially on the mobile devices, I moved a lot of the implementation out of the Haxe code and into the C++ code. This was things like when you try to get the width of a display object, it's really got to work out if the matrix has changed, and if the matrix has changed, has a line width change, and it's quite a complicated set of things you need to do just to calculate the width of an object. So putting all that in C++, at the stage, took it out of Nico, which was slow, and made it run faster. And in fact, it ran faster than the native Haxe CPP, than the CPP. Also, that's when CPP made it into the Haxe version 2.06, which is really kind of the first time that I think other people could use it if they wanted to, or at least give it a go. Before then, it was really far more experimental. And around this time too, Apple changed their terms of service to insist that any application for their App Store had to be written in either C++, C, JavaScript, or Objective-C, had to be originally written in it. So some ways you could be interpreted saying you can't use the CPP as a way of producing code. So I wrote a pretty scathing blog post, which I think Steve Jobs must have read, because later they updated their terms of service to relax that rule. Also, had a first look at the Android port. Now, again, to compile to the Android, it was really nothing special because Android had a native target, so you could just compile your code to C++ as a DLL, bring it into an Android project. Now, setting up an Android project was really quite complicated for the native case, because you had to set all the directories up in the right structure, put the binaries in the right spot, rename a few things, set up the calls from the Java JNI into the C++. But it could be made to work. It was just slightly painful. So in 2011, I worked on the enemy build tool, which makes things easier for generating a whole new project. Now, this was based on the Haxe CPP build tool, which I think has been pretty successful in allowing you to target like completely new compilers, Xcode or Android, Linux, Mac, Windows, really just by changing a small amount of configuration data, which is really the flags and the compiler names required to generate to actually get the compiler to run. In some cases, not so simple. Some compilers hide their flags, so you've got to try to reverse engineer or put some debug on to get them to cough up exactly what flags you need to compile something. Windows has taken to hiding their executables, so you can no longer find them in the latest dev kit installs. But ultimately, the CPP build tool, I think, has been quite successful in allowing XhX CPP to extend into all sorts of different targets. The enemy build tool is pretty much built on the same or similar technology, and it's made creation of new projects for Xcode on Android in particular quite easy. But it also was quite general and allowed other people, such as Joshua, to add the WebOS and the BlackBerry targets effectively within the same framework without really needing to change much of the underlying code. So 2012, off to my first Haxe conference. And I think this is maybe where the Haxe target first gained a bit of visibility. Before then, maybe not too many people knew what it was. I talked about an architecture at that conference of the compiler creating CPPs and H files, and then those files getting compiled into a binary. And actually, that architecture is still there today. So I guess in 2012, it's really approached its final form. In the talk there, I listed a few of the issues with the system to do with garbage collection, strong typing, native code integration, and these are actually probably all still kind of issues today. So I guess they're just hard. I have had several attempts at solving them, but have never quite got it right. The built-in debugger was also introduced then, but it hasn't had much love. So it's still could use some more work. So 2013, OpenFL forked off from NME. The idea was that NME would form the native implementation backend for OpenFL, and then other backends could bypass NME's as a backend and do their own implementation. Since then, the NME and OpenFL implementations have drifted apart, and I don't think there's any NME code at all in OpenFL now, although they're still compatible in principle because they both support the Flash API. So theoretically, you could run the same code on both with a small amount of effort. And also, in the end of 2013, I took a little break from Haxe, so there's not much else to report from around then. But 2014, back to the Haxe conference. Haxe had new metadata, easy to access from within the compiler. This allowed you to annotate classes and with additional information. And this was quite useful for native integration, and using it to inject extra header files or extra C code or extra includes or build commands became quite a lot easier with the metadata. So that was probably where some of these native integrations started to come about. I also got back into NME and rationalized the development by dropping many of the targets. So at that stage, NME was just supporting the desktop and the two mobile, Android and iPhone. At this stage, actually, Flash was also waning as a target, mainly because I wasn't using it at that stage. So, and then in 2015, there was I introduced Sepia, which is a second target for that C++ backend. The idea was to come up with a way of completely encapsulating a game into a single file, much like a Swift file, where you've got the code and the assets all zipped in to a single binary. So I needed some kind of bytecode. I tried Nico as a possibility, but it was going to be too slow, and it has some issues with the way it dealt with fields by index rather than by name. I looked at using the ABC bytecode from the Swift project, but that also was a little bit complicated. It had some namespace primitives and things which I didn't think fitted very well with what was already there. And I did look at JavaScript, but it was difficult to work out how to mesh the JavaScript garbage collector with the CPP garbage collector. You really would need to be running them off the same system so that references to one are references to the other. You don't need to set finalizers or anything. So the solution was Sepia, which is a bytecode, and you generate it just straight from the Haxe compiler. And the thing about the Sepia is that as its host or virtual machine is generated by the CPP backend. So you compile your application with XhX CPP, and this gives you a program capable of running the scripting language. But because it can export all the class names, all the function names, and everything automatically, it made it much easier for the bytecode to sit on top of the Sepia, the Haxe CPP objects. And you can do things like extend objects, implement interfaces. In fact, anything you can do with normal C++, you can do with Sepia, but you can load it dynamically and load multiple scripts dynamically. So it's quite a nice concept. And with Academy, which is the NME host, it did actually achieve the idea of having a single file which contained the code and the assets required to run a game. Also, I introduced CFFI Prime, which was an update to the existing foreign functional interface, which which at the time was based on the Nico FFI, which effectively involved boxing all the values through the function calls. The problem with this is that the boxing would generate a garbage collection event. So the more calls you made, the more garbage collection you'd have to do. Now with the CFFI prime, it doesn't box the values. It creates just a native function pointer, and it's about as fast as you can get for calling into native code. Well, maybe not as fast as LuaChip, but fast anyhow. Yeah, so that was a new technology, and I think that's where I've sort of been moving everything towards. Of course, there were some garbage collection improvements where I inlined some of the functions and also created a parallel collector so that the pause times for collection were reduced. So 2016, I did quite a big refactor of the internals of the Haxe CPP Target. I'd learned quite a few lessons from when I implemented the Sepia structure. Sepia came 7 or 8 years after I'd started learning OCaml, whereas the XhX CPP Target was developed as I learned. So there was quite a few things that I would have liked to have done different, and in 2006 I did do them differently. I used the common code base between CPP and Sepia and extracted some of the some extra typing that Haxe CPP does. That got extracted out into common code, so really tidied up the internal implementation in the compiler. Of course, there were more GC optimizations at many levels. There was better structures and some more inlining. I also stopped shipping binaries with XhX CPP at this stage. Originally, I would ship the standard libraries, which were regex, the std or sys libraries, and zlib. They were shipped as separate DLLs or precompiled .libs. But I started running out of, I started having too many targets because we had to support iPhone, Android. iPhone had 32, 64, i7, and Android also had 2, and if you wanted to include an emulator, there was another 2 targets. So really there were just too many libraries to ship. So instead of shipping binaries, I added a compiler cache, which effectively compiles the libraries once on the developer's machine per architecture that they actually use, and then can reuse it between projects. But this also works really well for other source code that gets shared between projects. For instance, if you have a print hello function, there's a whole bunch of runtime libraries that get compiled in there, which can take a little while with XhX. But if you go and start a second project, it actually only has to compile one file, and all the rest it can link straight in. So the compiler cache really saved a lot of time, and also by reducing the number of binaries I had to ship, made the CPP library actually quite a bit simpler. So 2017, I added some additional Objective-C implementations into integrations into the Haxe compiler, which basically allows you to implement an Objective-C protocol with a Haxe class, which means that you can then pass a Haxe class off to a lot of the standard functions that are involved with interacting with the system, with the native iPhone system. I also added JS prime target to NME. Now, I was trying to get back to having a web target, having largely dropped Flash and removed the JavaScript implementation from NME because it was too complicated for me personally to support. So I was looking around, and by 2017, web technology had improved. They had the Emscriptum compiler that allowed you to compile native code into JavaScript. So first attempt, I compiled Haxe generated XhX CPP straight into JavaScript and loaded that up, and that actually does work. It's a little bit of a problem because it's running like its own virtual machine inside a runtime which is designed to be a fast virtual machine on its own. So it seems like a bit of a waste not to be using like the JavaScript virtual machine in itself. So I decided that, well, I want to compile the Haxe code into JavaScript and get that to run in the browser. First thing I did was compile the NME runtime, which is C++, using mscriptum into JavaScript, so that works. And then the JavaScript can call into that and create objects and put things on the screen, that works. But it can't automatically clean up after itself. The problem here is that JavaScript in a browser doesn't let you register any kind of finalizer on their objects, so you can never know when a native resource is no longer in use, so you can't automatically free it. So after thinking that might be the end of that, I actually came up with a scheme that works pretty well, where for the native objects, when there's no longer a reference, when there's no longer a native reference to a native object, but there is a JavaScript reference to the object, the resource serializes itself into JavaScript bytes and stores itself in the JavaScript object. Now this way, if the JavaScript object goes out of scope and disappears, that's fine. That's the end of that, cleaned up correctly. And if it doesn't, then the JavaScript object can reawaken the native resource from the byte stream. So doing it this way actually allows the NME.js prime target to actually share like 99% of the code between the desktop and the browser. So if you have a bug in one, you basically have the bug in the other. And the performance is actually really very good. So there are some things you need to worry about, like you don't want to be thrashing the creation and destruction, or the serialization and deserialization of the object. But within sort of a few simple things that you can do, it worked quite well. I also moved native integration to use the CPP star reference rather than the CPP pointer object. The CPP star just sits in your native code as a native CPP pointer, rather than being wrapped in a structure. And I could achieve this because I actually built the logic for when you need to make a pointer into a dynamic object into the Haxe compiler, rather than relying on the C++ compiler to do it with type transforms. Again, garbage collection got another workover, this time with a cached thread local context. So previously, every time you went to allocate an object, you would need to get the garbage collection context from the thread local storage, which is a bit of a system call. It's not too expensive. It takes 5 or 10 instructions, but I could actually cache it in a local variable, which sped up multiple calls significantly. I added an experimental generational garbage collector. The idea here is to be able to do a lot of small collections rather than one large collection. That's been in there. I'm not sure how many people are actually using it, so still can't really confirm whether it's production hardened yet or not. And Sepia got just in time compiling on all the Haxe targets that XhX supports, which is ARM and x86 64. So 2018, I've changed the string implementation of XhX CPP over to be optionally be UTF-16. Previously, it was UTF-8, and prior to that, it was UTF-16. So it's gone there and back again. I changed to UTF-8 in order to be compatible with Nico, and probably a lot of C function calls would probably be expecting UTF-8 strings. But I changed UTF-16 to match JavaScript, which I think is probably sensible. I have been entertaining the idea of using a even more complicated version, effectively UTF-32, where you can support any characters with a single point. but I guess I'd be interested to hear other people's opinions of that. You're going to have to write the code for handling multi-byte characters in JavaScript. You're probably going to have to deal with it anyhow. But yeah, I'm sort of interested in opinions whether it's an issue or not really an issue either way. If you're using the native string class, like the raw access to that HxCP string class, you might be in for a bit of a shock if your code gets compiled to UTF-16, because it is possible that the underbar _s pointer is pointing to a wide char version of the string instead of a single byte version of the string, which means that if you go to print it out, you might only see the first character. So that's something to watch out for. If you're using the CFFI functions, it should be all right, because if you ask for a char star, it'll give you the UTF-8 string, or if you ask for the wide char, it'll give you the UTF-16 string. So, but that's something to watch out for, and we might need to do a bit more education on that point. And around the beginning of 2018, my career was at a bit of a crossroads. The company I'd been working for long term went out of business. So I was doing a bit of contracting and a bit of this and that, and I was looking around for what the next thing to get into was. And this time I didn't choose gaming as the way to go, mainly because of the commercial realities of it. I didn't think we're probably there at this point of the century. But instead I decided to get more into AI and ML, which I think is probably, at least for the next few years, like a more lucrative field, and I've done quite a bit of it. So that's the direction I've been heading. But I guess the roundabout way of that is that I started using Haxe and NME to build a little GUI front end to some of the machine learning stuff I've done. So, you know, while I started out a long time ago with the vague idea of making games and not really know where I was going, I ended up coming out at the other end building these desktop apps with Haxe and NME, but maybe not the kind of apps I'd envisaged when I started. Yep, so this brings me back to the beginning. 2018, Eagles won the premiership again. So yeah, they were there just to bookend my Haxe journey. Still cheering me on for my next phase of Haxe. So what is next in our future with a computer? Almost certainly will involve improving the GC at some stage, since that seems to have been a fairly constant theme. I guess making the generational stuff more prominent and working fully, mainly to reduce pause times, would be ideal. I think we're going to run into a few issues with Int64, not so much calculations, but things like array length and buffer sizes. I think really, and file offsets and things like that. I think Int32 or signed Int32 is probably not going to be enough. So I'm not really sure when or how that'll be implemented. Better native integrations is always something that people have asked for. So I guess there'll be more of that. Personally, I've been using the CFFI prime style for my native integration, so I don't really have a burning desire to do other types of integration. But yeah, I appreciate that there's some demand there. Yeah, and more strong typing is also another theme we've had throughout my talks, particularly with anonymous functions. But it's come along a fair way now. I think I'll just give you a quick demo of this machine learning stuff I've been doing. This was a project I did in conjunction with a PhD student who was working on a project where they had to analyze the quality of a beehive based on the number of these brood cells that they're little baby bees in there. These ones have honey in them, those ones have little baby bees in them. So I ran the detector to automatically run over identify these cells, give the count of the top here. So these, previously you digitize these points by hand, and it takes like about a second to point. So some of these things would take, there's the hundreds of them. So they're taking half an hour to do manually, and they take about 2 seconds to do on the computer. The Haxe has proved useful. The fast bitmap processing, which just comes for free, really, because you're using accelerated graphics. Drawing the little dots, using NME and graphics API. Using threads to load bitmaps asynchronously, and caching stuff and running the background in the processing. Hooking in through CFFI into an inference library. All these things, I think, have been made easier by Haxe, or using Haxe, or I guess partly because I was familiar with the API, but partly also I think that the technology is pretty good. I really like the functional aspects of Haxe, where in order to create a thread, it's just like, here's a function, go off and run it in a separate thread, get back to me when you're done. So yeah, that's actually, I think that's about it. So anyone have any questions? I think it's that I like building compilers more than I like writing applications. That was the lessons I took away for the first few years. But I think I've turned that corner now, and I'm actually, one of the reasons why I gave this talk about what I've done in the last 10 years about rather than what's new this year is that I haven't really done that much in the last year. I think that's because I've switched back from being like a compiler developer to being the compiler user. So, but yeah, I think there's lots of great things to learn. Like I learned OCaml as a language, so that's that's useful. But learning Haxe as a language, there's techniques that you pick up from learning different languages that you can transfer over to other aspects of your coding. And I guess one other big lesson is that if you just plug away for something at 10 years, something good's eventually going to come out of it. So yeah, yeah. 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 So this is these are really just draw rectangles ultimately. This is a native Windows control. This is just all draw rectangle really, one way or another. This is an NME. It's got clip rectangle, so that makes some of that stuff easier. If I was to exceed probably 8K of the image size, it just go black. So there's some stuff in there that's maybe not. Actually, no, it rescales it down. So yeah, not super sophisticated. Some of these dialog boxes I'm thinking could probably be being native as well, but that's something. A lot of it is hotkeys. So there's and really trying to have a fast way of editing them, because there's two phases here. One is to be able to run it automatically, but really it's also important to be able to QA it at the end, zoom in, check. Like some of the ones with the more the more dense ones, you can kind of see where it doesn't work because it's got a nice regular hexagonal pattern. If you get the right zoom level, you can see maybe where it's missed one or not. It is basically an annotation tool. Yeah, it's like a vehicle for the. I think you can't just have an inference tool without having like a. And you know, actually to bootstrap this process, I had to digitize a bunch of these myself, and that's how I know it takes half an hour to do 1,000 clicks. You know. Oh yeah, yeah. So the CPP Target is you compile your code with like if you just start a test XhX print hello world. At the moment, you can compile that to Sepia with Haxe minus Sepia out.sepia. Then you can run it with haxlib run XhX CPP out.sepia, and what that does is simply call the Sepia host that ships with XhX CPP. So there's one, the Sepia host that ships doesn't have anything special other than the standard stuff, the regex and the syslib. The idea is that you can put whatever you want in the host. So if you're running your own like NME application, you would put all the sprite classes and all the bitmap classes and everything like that. You put them in the host. This generates a file which is simply a list of classes that is in the host. So then when you go to compile your application, say it's just a simple class that extends a sprite, it'll go, all right, I now need to generate the output for this sprite class. I've already got the sprite class in the host, so I don't need to output a sprite class. So ultimately, it'll only be the code that you actually use. And then to run the code, there's a CPP, in the standard library ships cpp.sepia.host run script. And what we'll do is load your script up and hit the entry point, not just like your main, your static main of your script. Now you can get it to run other functions within it rather than just a main. And if you want this, you can load up multiple scripts quite easily. So you can use it like a plugin system where it works pretty well. It's got JIT compilation, but it hasn't really got optimization. The bytecode format itself is very much just an AST listing. So it's got enough information that if I really wanted to optimize it later, I could. But at the moment, it just does a relatively straightforward, naive implementation of the AST. JIT compiles it. So it ends up about twice as slow as CPP. But that's for the code that's running in the script. Now, if your code is extended a sprite and your sprite's doing all the work, and maybe you just set the name, it runs effectively infinitely fast. So, yeah, that's quite a. Yeah. I'm a little bit surprised it hasn't really taken off more, but maybe because I haven't advertised it enough. Yeah. Yeah, it's slower than Hashlink because I haven't really optimized the AST, but not like crapload slower. But really, the concept with the Hashlink is that it's all Hashlink, whereas this is that you build your host and it's like a script on top of it. So potentially still could be faster. Yes and no. They do almost the same amount of work, but when CPP dumps out, it dumps out multiple files and does things like make sure you don't overwrite the timestamp and some things like that. The Sepia dumps out a single file, which would be generally smaller as well. So, yep, absolutely compiled. So it gets compiled into bytecode. Sorry, yeah, by the Haxe compiler. Yeah. Sorry? No. The JIT compiler is actually built into the XhX CPP runtime if you enable scripting in your host. And it's not a lot of code. It sort of tends to simplicity rather than speed at this stage. But yeah, so it is. Yeah, it's just the bytecode that Yeah. Yeah. No, I mean, I've thought multiple times about having a tool that maybe, or even just something like Swig, that even using an existing tool to generate all the glue files um, for for Haxe, which wouldn't necessarily be only the CPP target. I think with the CPP target, it's tempting to just hook straight into the hash include the header file and call the functions, and that does work, but I think you still need to effectively write the externs. I was thinking about Justin's project that maybe there could be a use there to anything that gets used by one could get used by the other, really. And you would just really wouldn't need to write the FFI layer itself, because you could just call it, or you still could with a DLL and have a strongly typed function pointer like the CFFI prime, and that would still work as well. Yeah.
Right up to today, that there's something I haven't yet found. How I should be. Is there the practice of
Yeah, not like a. Well, last Haxe conference, I did a workshop on it. It should be on video. Yeah, that might be. Yeah, I guess as far as best practices go, I don't think there's any real. Yeah, I know what you mean. I don't think there's anything that's definitively say just do this. I mean, a lot of people have been using the externs, and including the header file and doing that. And I've sort of tried to keep that going because I understand it's useful, but I'm not actually really using it myself because I prefer the CFFI prime way of doing it, because it separates it out sort of nicely. There's the end developer doesn't really need to have all the header files and stuff on their machine if that's possible. So yeah, maybe I'm a bit a little bit slow to react to some of that, because I'm not sort of heavily involved with that. Sorry? Anything that you compile XhX CPP on, you can use Sepia on. So, because the host is basically just a CPP program. Yeah. Yep. Now, if your script relies on a function in the host that's not in the host, it won't work. So, as long as you compiled it kind of against the same host specification, yeah, it should be good. You can disable JIT for sure and not ship it at all. So run in interpreted mode, which isn't great, but again, if you can offload most, like if you had something like a physics simulation, you'd use the scripting to create the physics objects, but not necessarily update them, then it should still be like acceptable, I think. Yeah. Thanks. One more.
So, if you were to give advice to
don't do it, just don't do it. Sorry.
what guidance would you? So, 10 years, you see acting all the language.
Not sure I'll speculate too far, but obviously there's a strong gaming support for it. It's still used like in production, probably more this year than last year, so it's still increasing. So I think if you're in the gaming space, it's well supported. I think some of the JavaScript space, it's unfortunately underrepresented because I think it's a great solution. But you know, I can't really speak for the JavaScript guys. So yeah, I mean, no technology lasts forever. You know, we've seen everything come and go. Haxe is still here 10 years on, so it's as good a bet as any. Just get into it, and you know, the language itself, I guess, is relatively complete. There's some things, you know, with asynchronous seems to be a bit of a theme that it might need to get to, but apart from that, you know, if we look at some of the features that were added, sort of tweaks to this and that, just make it easier and more comfortable without really being huge paradigm shifts in the way things are done. So I think it was just going to get easier, but yeah, still good all along. Yeah.